Alrighty, welcome to Evian-Drinking Kangaroo. There he is right there, and there is his Evian water. Hey, this is a watch me video, so all you have to do is watch to see how I solve this problem, but pay close attention because the next one we're going to do together. So you'll actually get a pen and paper out, or actually pencil and some highlighters, and you'll do the problem alongside with me, okay? So, anyway, here we go. This is the scenario. You are a scientist studying the strange occurrence of a kangaroo, right here, that drinks nothing but Evian water, right there. You are tasked with the job of making sure that the kangaroo drinks the correct amount of water. You have 5 bottles of Evian water. You must feed the kangaroo exactly 2/3 of all the bottles of water that you have. So, how much water will you give the kangaroo? Well, the first thing I always like to have kids do is write the question. And the question is, what's 2/3 of 5? 2/3 of 5 bottles of water, right? So once we do that, of means times, so I'm really doing 2/3 times 5, right? Well, if I'm doing that, let's come back to the question again first. What's 2/3 of 5? The first thing I want to do is create a fraction box, and I want to make 5 fraction boxes. And let's go ahead and do that right now. So I'm going to shrink this and give myself a little bit more room. And I'm going to draw 5 fraction boxes, and let's do that right here. So I'm going to go 1 and 2 and 3, and whoops, I want to straighten these out. 3, and then I got 4 right here, and I'm going to draw a 5th one. And they don't have to be perfect, but you want them fairly close, right? So now I'm going to cut each of these into thirds, right? And 3 parts means I'll draw 2 lines in each. So I'm going to go 1, 2, 1, 2, 1, 2, 1, 2, 1, and 2. And that gives me 3 parts in each. 1, 2, 3, all the way through, right? So I've got 3 parts. Now, I get 2 out of the 3, right? So I'm going to color in, and I'll use blue because, hey, this is water, right? So I'm going to color in 1, 2 out of the 3, and then color in 1, 2 out of the 3, and then color in 1, 2 out of the 3, and 1, 2. This one I'm going to try and make a little better. This one's a little off, huh? All right. And then finally 1 and 2 out of the 3, right? So now I can simply count these, right? And I've got 1. Oops, let me use black here. So I'm going to get rid of that and pick the black color. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But these are thirds, right? Because I got 1, 2, 3, right? So I got 10 thirds. Let me just write that down here. I got 10 thirds. And that, my friends, is how you would do the mathematical model. You end up with 10 thirds. Now, 10 thirds, if you notice, is top heavy, or what I call also called an improper fraction, right? So we're going to do something with this a little bit later. But before we do, let's go ahead and look at the algorithm. Now, the algorithm, you simply are going to take 2 thirds and you're going to multiply it by 5. All right? So the first thing we do is we look at this 5 and we need to make it a fraction, right? And 5 is really the same as 5 out of 1 or 5 wholes, right? So let me show you how I do that. 2 thirds times 5 over 1, right? Now the reason that works is because it tells us we have 5 wholes, right? Or 5 out of 1. So this would be like 5 boxes that are all filled in. Now, multiplication is different than adding and subtracting. With adding and subtracting, I must have common denominators. With multiplication, I don't have to. With addition, I only add or subtract the numerators. But with multiplication, I multiply the numerators and I multiply the denominators. So watch what happens. I got 5 times 2, which is going to give me 10. And then I have 3 times 1, which gives me 3. And as you see, this agrees with our illustration right up there, our mathematical model. Now, because this is top-heavy, the next thing I have to do is reduce it or simplify it. Now, to simplify a fraction, you could think of fractions in 3 ways. I always say this. 10 thirds, 10 out of 3, which is what I did here. I got 10 out of the 3. Or 10 divided by 3. So, let's go ahead and do that. So I'm going to take 3 and divide it into 10. And 3 goes into 10 3 times, which gives me 9. And when I subtract, I get 1. Well, your remainder is always the numerator, and your divisor is the denominator. So I get 3 1/3. Well, let's see how that would look over here if I change these around a little bit. So let's enlarge this again. I'm going to come right back here. So now, if I move some of these pieces, I can create holes, right? So let's go ahead and I'm going to first move this one right here, and I'm going to move it right on up here, right? And now that creates one hole there, right? Then I'm going to take this one, and I'm going to move it. I'm going to put it right here. Whoops. Right here. And that's going to create another hole. And then I'm going to move this one right here, and I'm going to move it right up there. Now, if you look, and I'm going to make this a little thicker, you can see that I've got one hole here, a second hole here, and a third hole right there. And then I get 1 out of the 3 left over, right? Because I got 1 out of 2, 3. So I get 1, 2, 3, and 1/3. So let me shrink this again so it's not quite so thick. So I get 3 1/3. And as you see, that agrees with my algorithm that I did right here. 3 1/3 is the same as that right there. So that, my friends, is how you need to solve the multiplication problems with your mathematical model and your algorithm. Until next time, I hope you have a fantastic day. I'll see you soon.